Hello guys. So there's a lot of videos going around about this Atlas 3i, and admittedly a lot of them are AI slop, but I'm going to give you something a bit special here that is definitely not that. Some solid data which talks to the issue of exactly what it's doing in the solar system, its mission if you will. Now, I'm certainly not of the view that it's a comet, okay, and the evidence I'm going to present in this presentation should decisively prove that. A lot of people have been looking at this Atlas 3i object, and they've been looking at it a lot of the time just focused on the object itself and the anomalies associated with it. So they're saying things like its colours changing, stuff like that, or it's not emitting iron but it's emitting nickel, or it's got some kind of inverted tail, an inverted cometary tail which is not pointing away from the sun, that kind of thing. All that is very interesting, don't get me wrong, but if you want to really understand the mystery of this object, you have to study its trajectory. The actual path that it's taking through our solar system reveals everything, and it gets to the heart of some pretty esoteric things, because what I'm going to show you in this video is that this Atlas 3i object is in fact connected to solar flares which have already occurred this year, and also a couple of earthquakes as well, high magnitude earthquakes. It is tied in to these events, and the tie-in relates to the specific distance that Atlas 3i had from the sun and from the earth at the time of past solar flares and earthquakes. These are on the USGS, that's their earthquakes, the earthquake database from the official earthquake listings of the United States government. And then you've also got the solar flare data, again that comes from official sources as well. So I'm going to tie together this information in this presentation and reveal that its orbit is absolutely not random, and the specific way in which it is not random reveals something about what it is doing in the solar system. To begin the presentation then, we're going to start by looking at just something to do with the special nature of imperial measures and some of the numbers involved in it. So you can see with this first slide here, now this first slide is actually from my book, okay, you can get it from my website, but if you look to the left of the chart here, there's two little boxes, right? And you can see it says base 6 right here at the top, and base 6 again. And you can see going downwards in bold, we've got the basic 6 progression. It's 6 times 6 is 36, times 6 again is 216, times 6 again, 1296, etc., right? And you can see from these 5 values here, if we just multiply by 2 on each of the rows, you can see how the numbers obviously are bigger in a certain progression. And then we've got the reverse going off in the bottom box. We start out with 6 and we divide by 2, and you can see the numeric sequences here. Now this just looks like an exercise in numbers at this moment, which is what it is kind of, but the thing about it is the unit measures that we use, that we're familiar with, imperial measures based upon the foot unit, they are intimately tied in to these numeric sequences, these values here, when we start to capture or express certain things in nature using imperial measures. And in this case, I'm thinking of the statute mile, which is 5,280 feet. You can see one of the numbers here, the numeric sequence 432, just here, which is 216 times 2. If you go to 216 divided by 2, you get 108. Bear that in mind then, and have a look at the sun and the moon. You can see here then, on the left we've got the radius of the sun. The top value is what is the textbook value in statute miles, 432,163 miles, right? You can see how close it is to 432,000 dead on. It begins with that special numeric sequence. And if you look at the moon's radius is practically dead on 1,080 miles, only slightly above it. Again, very close, isn't it, to that perfect sequence as it begins. And this is based upon units of the statute mile that we're all very familiar with. Over here in Britain, all our road signs are in it. And for any of you guys in America, your road signs are, you use our measures as well. So this is something special to note about statute miles. And this critical point here is key to understanding something about how you can prove that the Atlas 3I object is itself on a non-random orbit. So if you go back to it then, you can see the code name. It says C/2025N1 Atlas. This is 3I Atlas. That's just the official code name on screen. And this is from the Jet Propulsion Laboratory. And these are all the orbital elements. So it's classified then, as you can see here, as a hyperbolic comet. That is, it's not got an orbit around our sun. It's got like a fixed path, if you will, coming from outside our solar system and just passing through on a little curved trajectory. And that's what you can see here. As of the time of recording, it's about the 11th of October here. And you can see the Atlas object. It has this slight curvature. This is its hyperbolic trajectory. It's just gone past Mars and it's going off here towards Jupiter. You can see where Jupiter is here. When Atlas 3I gets all the way here, Jupiter will have just gone past it, just around about where the mouse pointer is here. And it's so fascinating, right, when you think about the fact that it seems to get very close to a lot of these planets, right, to Mars and Jupiter in particular. And so this got me thinking. I did an analysis of the closest approach points of the Atlas object to all of the planets you can see, including the Sun, as you can see on the screen here. And I expressed them in statute miles. And when you do that, something quite extraordinary is revealed. Now, as I always bring the receipts, let's just show you exactly what I did with one example. We're still at the Jet Propulsion Laboratory's page here, their website, and you can see the Horizon system. And if you go to this very same page on their website, you can do exactly what I did. You select the target body as this Atlas C/2025N1, this is Atlas 3I, and you observe a location. In this case it's set to the Sun, to the centre of it. You can set it to other planets within the solar system. You can use the applet to figure out the general time when the closest point is between Atlas 3I and whatever body you're concerned about. And then you set the time specification and you can set the ranges even to the nearest minute. You can see its step in terms of minutes. So this is how accurate it is. If you do all that and then you click the Generate Ephemeris button, it will give you a big massive list which you just scroll down and you can see. And in this case, this is the sequence you do if you're just looking at the Sun, the closest approach point to the Sun. You can see in blue I've highlighted it. The specific time of the closest approach for Atlas 3I to the Sun, it says it here, 29th of October, 11 hours 44 minutes universal time. And the critical column is this one here where I've labelled distance AU. AU is astronomical unit, right? 1 astronomical unit is the mean distance between the Earth and the Sun. And all these values here that begin like 1.35 or so, this is 1.35 AU. But if you look very carefully at the highlighted value here, this value is less than all the values above and all the values below. If you just look at this sequence here, it says 4664. Above it, it's 4710 higher. And if you just go below it, it's 4665. So you can see this is the minimum value. This is the time to the nearest minute of its closest approach, according to JPL. So what I did then was, I did all of this for the bodies you just saw previously, worked out what the closest approach points were in AU, and then you go to the next step of multiplying them by 1 astronomical unit to figure out what the closest approach point distances are in terms of statute miles. So here is what you find. Let's start out with Mars. It got to its closest approach to Mars on the 3rd of October, okay? So this was just a week or so ago. And this is roughly what it looked like. At this particular time then, 4 hours 38 minutes universal time, the distance between Mars and Atlas 3I is this string here in astronomical units. Now 1 astronomical unit, you can see at the bottom of the screen here, is that value 92,955,807.267 miles. That is a standard textbook answer for 1 AU. What we need to do then is simply multiply these two together, and it will tell us in statute miles the closest approach point. And this is the answer. Practically dead on 18 million miles, okay? 18 million you can consider to be effectively an ideal, and the discrepancy from this perfect sequence, if you want to call it that, is only 1589 miles or so, which is like less than the diameter of Mars itself, I believe, roughly on par with it. So that's the first one to note. What about this one? The closest approach point to Jupiter. This will occur next year, 16th of March, 12 hours 18 minutes. Here is the distance in AU, according to JPL, multiplied by 1 AU, and the distance is this. You can see the sequence here, 33,329,000, etc. Okay, and that is very close to a perfect sequence of all threes, as you can see here. Very fascinating. There's only about 4,000 miles discrepancy in that. Next, we've got closest approach point to Mercury. Again, we multiply the distance here in AU by 1 AU, and the answer is, you can just see it there, 107,989,966. But look carefully at the sequence. It's very close to that one there, 108 million miles exactly. The error, 10,000. Now these discrepancies from these ideal sequences here, they are fractions of 1%, and I'm going to show you the table very shortly. But you can see then, isn't it uncanny how all of these close approach distances, they're of these like sequences of numbers closely allied to the base 6 system, right? And these reveal themselves to be significant when you express these distances in statute miles. Let's go on though. This one is Atlas 3I, closest approach to Saturn. Now this occurred in May 29th, so this was a few months back. And the distance here is that. You can see it there, it's about 925 million miles or so. That almost looks random, but here's the interesting thing. If you want to figure out what the ideal is, just take the reciprocal. It really is the key to understanding it. If you just do the equation 1 divided by that number, you get this value here, 1.07997 times 10 to the power 9. Now look at the sequence. What is it close to? 108 as a sequence. So if you just do the reverse, assume it is 108 to the power 9, 1 divided by that returns this ideal figure here. An ideal closest approach, and it's essentially all 925s. 925,925,925.925. So there is the answer there. Now let's go on. What about the Sun? This is a very fascinating one, guys, and this reveals something very special. So here then, the distance between Atlas 3I and the Sun at its closest approach is this value. It's 126,087,761 miles. Now what's the ideal here? The answer, 126 million miles. Now this discrepancy here of about 87,000 miles, it's still only a fraction of 1% or so, but relatively speaking, this actual discrepancy is bigger than all the others so far, multiple times. And this got me thinking. The Sun is a massive body, and as I showed you right with the opening slides, its radius is 432,000, but there are many layers to the Sun. And so I went to NASA's own website just to look into this a bit more, and there's a very fascinating thing that you'll notice here. So this is NASA's website. You can see logo there. You can see that they give the outer radius of the Sun 432,000 miles. But look at the core, 86,000 miles. How interesting, okay? How interesting. When you think about it then, and you think about this figure here, you're thinking, wait a minute, maybe it's not about the significance of getting 126 million miles from Atlas 3I to the centre of the Sun. Maybe it's to the outer edge of the core. Well, hold that thought, guys, because we're going to return to that. But for the moment though, let's just look at the table. So far then you can see then the bodies we've looked at, Saturn, Mars, Mercury, Sun and Jupiter. Those are all the times of closest approach per JPL, all the distances in miles, the ideal sequences, and also the discrepancies from the ideals in miles. And look at the percentage error rates. This is what I'm talking about. Fractions of 1%. Now you will notice I've looked at the core here, and this one here, 126 million miles. I am assuming that the intent was to get to the outer edge of the core of the Sun, which is why this is not including the 87,000 miles or so. But let's just have a look then at some critical points, and this is where you really need to stand back, guys, and consider the implications, okay? Because this data categorically proves really decisively that Atlas 3I's orbit is very carefully selected and not random. I mean, I've seen some people say, oh, it's very close to the ecliptic plane, of the Earth's orbit around the Sun, and there's a 1 in 500 chance of that. What you're looking at here is data which blows that away massively. So let's just have a look at some of the ratios involved here, using the actual model distances, not even the ideal. So the first thing then is we've got Mars and we've got Mercury. So it got close to Mars first on October the 3rd, 438. And the distance here is nearly 18 million miles. Then it went on 5 days later, October the 8th, right? Mars was October the 3rd, Mercury October the 8th, so 5 days later, 2 hours 43 minutes. You can see the closest approach here. A simple division by these, look at the sequence, 5.9989. It's practically dead on 6:1 as a ratio, okay? Do you seriously think that this is a random orbit? That it just happens, amazingly enough, to get to its closest approach to Mars? You mark that distance. A few days later, it gets to its closest approach to Mercury, and it just happens that it's practically dead on a 6:1 ratio of these two distances. Do you seriously believe this is random chance? Let's go on. The Sun and Mars, same deal. You can see the ratio here, practically dead on, 7:1, if we take the value from Atlas 3I to the outer edge of the core. Incredible precision. What about Saturn and Jupiter? If you do the ratio of these two values, look at the sequence here. 0.03599, practically dead on, 0.036, like the prime number practically, the basic system, like 6 times 6 is 36, okay? We use degrees, 360 degrees. I mean, think about the implications of how accurate these ratios are. And one more, Mercury and Jupiter. This one practically dead on, 3.24, as you can see. When you look at these values here, guys, I'm telling you now, there is no way this object just randomly came into the solar system and has these closest approach points to the planets with these exacting ratios where the numeric sequences of the distances are very significant when expressed in statute miles. You've got to be thinking, A, this is an alien object, and B, they're using the same measures as we are. They're familiar with the statute mile unit. Remarkable, but it's one of the things I talk about in my book when I talk about measures like statute miles or the foot units itself, or even a unit length of 6,000 feet, which is the ideal geographical mile. Our imperial measure systems are tied in to nature itself. They're not arbitrary distance lengths. They're actually a special subset of wavelengths associated with a special subset of frequencies of propagating waveforms. But let's just continue on with this. What I want to discuss now are Venus and the Earth, two planets I have not mentioned so far. And this is where things get a bit varied and interesting. So here then we're looking at the closest approach point from Atlas 3I to Venus. And this is the yellow line, right? You can see it connecting up Atlas 3I to Venus. and this occurs 3rd of November 2025, 5 hours 56 minutes, right? Now, if you look at that line there, also at the same time, we have, no doubt, a distance between Atlas 3I and the Earth. So we have these two distances here, okay? There will be two distances simultaneously present at this time. It's the closest approach to Venus, it's not the closest approach of Atlas 3I to the Earth, but there's something special about both these distance units. If you take the both here then, as before, these are the distances in AU, and the last column here is the distances in statute miles. The ratio between them is very significant, practically dead on, 0.288, one of the values, associated with the prime basic system from the table previously. So, we know that at the same time as we've got this closest approach to Venus, the distance to the Earth is also a significant value in and of itself as it's connected to Venus via this ratio. But let's move on further. We can see then if we divide this by 8, so it's 0.288 divided by 8, we get this 0.036, which again, just compared, it's the same ratio value of the closest approach distances from Jupiter and Saturn, again further reinforcing what I'm saying, okay? But let's just go further still. I'm going to show you something special about this distance here to Venus and the speed of light. Now the speed of light in vacuum is 186,282.397 miles per second. Again, that's a textbook value, you can look that up, okay? A simple ratio reveals the following: 324.06, practically dead on 324. So that's like effectively how many seconds it would take for light to travel from Atlas 3I to Venus, okay, when it's at its closest approach point. Fascinating thing. We can now start to see how these values and these distances are significant in terms of propagating waveforms. Again, just for comparison, that 324 I mentioned, the Mercury-Jupiter ratio, again, more reinforcing connections here. Now, this is where we go back to the Sun and what I was talking about with respect to the significance of the 126 million miles and how it seems to be the distance between Atlas 3I and the outer core of the Sun. So, let's go back here to this. We've got on screen then the time, which is 11 hours 44 minutes universal time, 29th of October. This is when the Sun then will have its closest approach to Atlas 3I. Now, this 126 million miles would appear to be more accurately tied into the distance between Atlas 3I and the outer edge of the core, effectively. So we've got NASA's estimate here of 86,000, but I want to show you something else. Again, this is the speed of light, and it would appear even the speed of light is connected in some fundamental way here to the Sun. And we can actually derive, and I'm going a bit speculative, but in my book I show how the speed of light has been transformed, and it is tied in its transformation to the increase in the size of the Sun and a few other things. But what I'm going to show you here is how we can derive what I believe is an accurate and a very decisive measure for a refined measure for the Earth's core radius, okay, using the speed of light. And we do this by simply dividing it by 2.16. And again, that sequence, 216, divide by 6, you get 36, divide by 36, you get 6. So it's part of that sequence. In this case, we're using 216. Speed of light divided by 2.16 gives you this value here, 86,241.85. Now, we're assuming then, what I'm putting forward here is that this is a more refined value and very meaningful value for the, if you will, true radius value for the Sun's core. And in doing so, a lot of things are going to have a harmonic connection, which is going to be very significant. So if we add this value then to this ideal of 126 million miles, you can see we've got this new value here, 126,086,241 miles or so. That would now be the distance between Atlas 3I and the very centre of the Sun. And this differs, by, is it 1,500 miles? 1,500 miles? Practically nothing, effectively, from the JPL modelled answer. But just work with me on this, guys. If we then divide, if we divide that value there, that distance, by the radius of the Earth's core, you can see now how it has an almost perfect harmonic fit. It fits in a whole number of times, practically dead on, between Atlas 3I and the centre of the Sun. 1462.007. And this means that that same distance for the radius of the Sun fits into 126 million miles 1,461 times, one less. Now, the minute I saw this, I knew straight away the connection to the Earth itself. If you just take this value and divide it by 4, you're looking at a value which is practically dead on the orbital period of the Earth. It's closer here to the sidereal year than the tropical year, but it's a very small discrepancy. But I find this to be absolutely incredible. Now, why is this significant? Well, this is where it touches upon some of the work done that I mentioned on my website, loststagesecrets.com, and also in my books, and it's all to do with resonance, I mentioned how if you look at, say, the Great Pyramid, a functional device in ancient times, it had a base length of 756 feet. And I point out that it was meant to be set into vibratory motion. And one of the ways in which you can get something set into vibratory motion is through resonance, through resonant stimulation. So if you have a waveform, a propagating energy wave, and you strike an object with it, if the wavelength of that propagating waveform fits in a whole number of times to the critical dimensions of the target object, it starts to get agitated, This is like resonant agitation, and it goes into vibratory motion. If you were to take then the actual distance from the equator of the Earth, the elliptical arc up to the centre of the pyramid, the Great Pyramid's centre itself, and you took that distance and divided by the base dimension 756 feet, you get the sequence 14,400, practically dead on. It's one of these numbers that we're familiar with. And it's all about the fact that wave measures using effectively the equator as a nodal point would have been propagating with the same dimensions of the Great Pyramid all the way up to it, and therefore causing it to go into resonant agitation. When I see mathematics like this, where you've got this Atlas 3I object, it gets to its closest approach to the Sun, the most important distance you could say, respecting the Sun, and it just so happens that the radius of the Sun itself, of its core that is, fits in a whole number of times to the distance achieved at its closest approach. It suggests to me, it is highly suggestive of the fact that Atlas 3I would emit some sort of energy wave towards the Sun, and it would be intent upon choosing a wavelength which is some measure of the core radius itself. It could be the full core or just the radius itself, which would fit in to the core diameter twice. But it seems to me it's highly suggestive that Atlas 3I, and I do put this forward, that it is some sort of alien craft with technical capabilities. It would emit an energy wave to the Sun and stimulate it, causing it to go into resonant agitation, That is what I believe this mathematics here suggests. Now, when you think about it then, you could look at this in a couple of different ways. A scientific scan. Yes, resonant agitation could be something that you can regard as a scientific scan in that sense, just testing the Sun itself, so to speak. Interstellar communication, that is also possible. There are ways in which you can transmit information using stars, and it's an instantaneous method of communication from one star to another. This is something discussed in my other research, but I don't want to dwell upon it too much. But then we've got the third thing. If you stimulate the sun through resonance, this could produce increased solar activity, triggering solar flares or coronal mass ejections. That also is something that, I've got to say, it is a very intriguing possibility. But beyond that, guys, I'm going to put to you, it's very likely that that is exactly what Atlas 3I will do when it achieves its closest approach. There's compelling evidence for that. And it's what I said at the start of this presentation. What is the most powerful evidence that you could have which could make somebody think that Atlas 3I as an alien craft could stimulate the sun to trigger solar flares? Is if you could demonstrate it has already done this. And it would appear to have already done this. To say more about this physics, I'm just going to mention my book here, which you can get from my website, lostagesecrets.com. And so this book is Ancient Megaliths, Covert Military Bases and Nuclear Weapons. And I talk a lot about some very esoteric aspects of physics to do with, because it's all tied together, megalithics, structures, military bases, nuclear weapons, it's all very much tied together, guys. And the biggest or longest chapter in this book here is the secret physics of nuclear weapons. So I'm just going to briefly give you a little bit of an intro into one of the more classified aspects of nuclear weapons and how they function. And this very much ties into the relations we see with Atlas 3I. Okay, it really does get to the heart of what's actually going on here. So, this is essentially from my book, but I've done some better diagrams here than, because they're all in colour that you'll not find in my book. But what you're looking at here then is the database of nuclear tests of the United States. And this is 1945 to 1963. And I've highlighted two tests. One is called King, which is the 34th device that the United States tested. And also Castle Bravo. Castle series, the first device there was Bravo itself, device number 46. So there's about 2 years separating them or so. One's 1952, the other's 1954. Shot King stands on record as being the highest yield pure fission device ever tested by the US, and Bravo is literally the highest yield device, period, ever tested by the US, at least officially. And that was a 15 megaton device here. So, let's have a look at, firstly, King. And here's where you have to consider something very fascinating about these weapons. Most people are familiar with the fact that the nuclear devices, they have a certain internal process, usually using something like plutonium, and you implode the core to get a chain reaction effect. And through the process of fission or fusion or a combination of the two, you release a massive amount of energy. Now, you might be thinking that the internal workings of the device itself are enough to produce the energy output, that is the massive explosion. And that alone, those considerations alone, produce the outward yield. But this is not so. It turns out that the position, quite literally, of the sun relative to the devices affects the yield. And this is because waveform patterns actually link up the ground position of the sun to a device at the moment that it is triggered. So you can see here then, we've got the King device, 15th of November 1952. The precise time, 23 hours 30 minutes universal time, when it was triggered. We've got the coordinates of the bomb itself here, latitude and longitude, and this is, here you can see in red, the blob here, this is at Eniwetok Atoll, and that's where the bomb was when it was triggered. At that precise time though, you can also work out the ground position of the sun, okay? That is, if you imagine freezing the solar system, freezing the Earth's rotation on its axis, and at precise time, draw a straight line between the centre of the sun and the centre of the Earth. That line will pierce through the surface of the Earth, and those are the coordinates for the sun, its ground position, if you will. So, at this moment in time, you can work out the Great Circle separation arc, and this is the yellow line here, the yellow curved line. and you've got the answer expressed in feet. Now, that is no arbitrary distance. The people who were experimenting with nuclear weapons worked out that there were certain distances of separation between the sun and the various devices they tested, which were beneficial to boosting the yields. And so they worked out the core distances and then used harmonics, that is, they divided them by various whole number values so that waveform patterns would fit a whole number of times in them. And they figured out what these were. And there are many examples of this in my book, okay? But I just want to show you how this applies to Atlas 3i. And I realize I'm getting into some technical stuff here, guys, but please bear with me. All will become clear. So you can see here then that this is what you've got for King. If you go to Bravo, it's the same deal. You've got coordinates for the bomb and the precise time it was triggered, 1954, February 28th. You've got the sun ground position. And this is the arc length, the instantaneous arc length fleetingly established because the Earth's rotating. And this is the arc length fleetingly established. You can see it in the box here. And it's about 35.8 million feet or so. But let's look at the ratio between them, okay? This is the fascinating thing. A simple division, one ratio that you can see from these two values, and the answer is 2.6666 recurring, practically dead on. And the error from this perfect sequence is 206 feet. Bearing in mind that the Earth rotates on its axis and sweeps out about 1,526 feet per second. So when they are triggering these devices to the nearest second, it turns out historically that this ratio is achieved with precision, a ratio of 8 divided by 3. Now, why is this important? What were the scientists doing? Well, they knew that the wavelength, that is the curved great circle arc from King to the bomb in 1952, they knew that that as a distance was a fundamental wavelength, right, that helped boost the yield of the device. And so they reasoned the following. If they simply divided it by 3, then multiplied that value by 8, they then waited in 1954 for the Earth to rotate around. They got the coordinates where the bomb was going to go off for Bravo, and they had to wait for the sun separation distance to Bravo to be that value, right? Which is basically the King value divided by 3 and then multiplied by 8, this 35.8 million feet. And only when it was achieved, they then triggered Bravo. Why? Because they knew it would have a beneficial effect in boosting the yield. Here you can see then, when you see ratios like this, and there are many in my book that I give examples of, when you see a ratio like this, basic ratios, various values, connecting up arc lengths from various components of one nuclear device to another, you get the sense, yes, there's a certain physics involved here, a physics of resonance. Somebody is playing around, if you will, with wavelength measures, and they are using them in order to boost energetic effects, okay? I realize that seemed like a big digression, but bear with me. We will now return to Atlas 3i. This is the space weather website, spaceweatherlive.com, and here's where we're going to have this solar flare connection I spoke about. So, you're looking then the top 50 solar flares for the year 2025. And you can see here I've highlighted the third one, the X1.9 flare. X-class is the most significant, the highest magnitude flares, right? So this was an X1.9 flare, and we've got the date here, 19th of June. And you've got 3 columns. You've got start, maximum, and end. Now, what are they all about? Well, because we're monitoring the sun continuously, when we start to see, literally start to see energetic activity start kicking off, right? We register the time, even to the nearest minute here. That's when the sun starts to get into this agitated state. In this case, it was some 13 minutes later that you get the maximum time, and this is when the solar flare is released in this big burst. The end of the activity is, again, it dies down until it gets to, you could say, normality, right? In this case, another 4 minutes later. But I've highlighted in particular the start of the activity. You can see You can see there it's 23:37, and again it's universal time. Now because we've got this precise time here, we can now go to the JPL site to figure out the distance between Atlas and the Sun at this time. You can see it right here. There's the Atlas 3I target body, the Sun body centre, and we've just specified the same time, 19th of June, 23:37. And you can see the value right at the right side of the screen, 4.88 or so AU. So the following allows us to convert it into statute miles. So we've got 4.88 multiplied by 1 astronomical unit, and you can see the distance then is this value in red here, okay? About 453 million miles or so. So at the precise time of that 1.9 X-class solar flare, right, when the activity started to the nearest minute, the distance between Atlas 3I and the Sun is this red figure here, 453 million miles. Now back to this. On the 29th of October, a few weeks from now, Atlas 3I will arrive at its closest approach point to the Sun, and the distance between Atlas 3I and the centre is this value here in orange, this 126,086,241, right? You can see in red, this is the time of the closest approach, this time here, and it'll be 126 million miles to the Sun's outer edge core, and the orange figure is Atlas 3I to the centre of the Sun. Now, bearing that in mind then, there is the figure that we have just determined. That figure then, this 453 million miles, was present, right? That was the separation distance between Atlas 3I and the centre of the Sun when that X 1.9 flare occurred. So now we're going to do a simple ratio between these two figures in orange. And what do we find? The answer is practically dead on, 3.6. 3.59999. Now, 3.6 is the numbers 18 divided by 5. That's the ratio as a fraction. Think about Bravo and King, those nuclear weapons, and then look at this and think the implications. If Atlas 3I triggered this 1.9 flare, this X-class flare, right, 19th of June, it means that that wavelength measure, this value here in miles, is not just an arbitrary distance of separation. It's a meaningful wavelength measure, and the Atlas 3I, being a technological device, emitted some kind of beam of energy to the Sun. It stimulated it, triggered the flare. And so what is the implication? Well, the implication is if we take that figure there, 453 million miles or so, divide it by 18, and then multiply by 5, we get this 126 million and 86,000. We get the distance that will be present in the future, 29th of October, right? When Atlas 3I gets to its closest approach to the Sun. The implication, the suggestion, what is implied here, is that that will be a viable time to fire yet another beam to the Sun to trigger another high magnitude solar flare. Now, I do not believe it's firing standard electromagnetic beams as we understand them. I believe it's firing scalar beams. That is where you merge electromagnetic beams 180 degrees out of phase. So qualitatively, you're using a different type of beam, but the energy effects are enfolded. I do believe when you look at that analysis I did previously, talking about the 1462 connection, how when you're at the closest approach, Atlas 3I to the Sun, the core radius of the Sun fits in 1462 times exactly. Here with this connection, thinking about the physics involved with nuclear weapons, there is a strong suggestion here, guys, that we could have Atlas 3I trigger a solar flare when it gets to its closest approach to the Sun. That is what is suggested here by this analysis. But let's go on further, because now we need to talk about earthquakes. Here you can see then, this is from the US Geological Survey, USGS, and these are the top 5 earthquakes, the top most powerful earthquakes to have occurred this year. So if you did a search on USGS 1st of January to present time, you get 5 earthquakes, and these are the 5 earthquakes. So I want to point to this one here. Okay, you can see Southern Drake Passage, and it's actually the one right at the bottom, just near the tip of Antarctica and South America. It's that white blob there. Okay, that's the one. All the others, the other 4, they're all really high up, right? This one here is the white blob here. Now you can see this one that's in a slightly lighter blue colour. That one actually is this 8.8, okay? It's just in a lighter blue colour, marking the most powerful one. But the one we're interested in is the 7.5 one, which is the white blob here, okay? So, first thing I just noticed as a passing curiosity is, look at the timestamp of it, universal time, 2 hours 16 minutes, okay? 18 seconds, but 216, quite fascinating. So, because we've got the exact timestamp here, in this case the nearest second, but we'll round it to the nearest minute because that's the accuracy we're dealing with, we again can do an analysis. And here I want to point to the particular timestamp of interest here is the closest approach time between Atlas 3I and Venus. So this is a slide I showed you previously. 3rd of November 2025, 5 hours 56 minutes universal time. When you get to this time then, we're going to have a distance between Atlas and Venus, which will be the closest approach, but we'll also have a distance, obviously, between Atlas 3I and the Earth. And that distance is what I want to focus on, and you can see it labelled here. This is the value in miles, and it's about 209.6 million miles, this figure here, okay? We know that both of these distances are significant because they're connected by this 0.288 ratio. But I want to focus upon the distance between Atlas 3I and the Earth at the time when Venus has its closest approach, okay? So, let's go on a bit further. Here you can see then, the value then, this is again the top value. This is a distance between Atlas 3I and the Earth that will be achieved in the future. As of me recording this right now, okay, this is about 12th of October. So November the 3rd, in the future, a few weeks now, the distance between Atlas 3 and the Earth is this 209.6 million miles. But that's the accurate figure in yellow, okay? Now, when I did the calculations and looked at the distance between Atlas and the Sun, okay, it is a connection to the Sun, but they're quite interchangeable. It's an odd sort of thing here, guys. It doesn't need to be to the Earth. Remember how I showed you even how that ratio connection involving the Sun's core and its distance, it gave us that 1461 figure divided by 4. It gave us the sequence of the Earth's orbit, even tied into values seemingly connected just to the Sun. There are connections of an indirect nature. But here we've got then, for the 7.5 magnitude earthquake, the precise time it occurred, the distance between Atlas 3I and the Sun is this value here, okay? And this value is about 262 million miles or so, but this is the accurate value. So all we do again, let's just look at the ratio between these two figures. Practically dead on 0.8, which is the fraction 4 divided by 5, okay? Again, think Bravo, think King. What is being said here? What is the implication, right? It basically means that there seems to be a connection here. This is what is suggested between the Atlas 3I object and this 7.5 magnitude earthquake, and that the distance between Atlas 3I and the Sun at the time the earthquake occurred, that value, as you can see, this 262 starting value, yeah, it's not just an arbitrary distance. It is a meaningful wavelength of some sort, right, of an energetic nature. And if you take that value, divide it by 5, multiply by 4, and you get the figure in yellow, 209.6 million miles. This is a figure that will be achieved. So the implication is, if we get to this point here, 3rd of November, 5:56, the energetic value, the wavelength measure, okay, is viable to trigger a high magnitude earthquake, okay? That is what this mathematics is suggesting. So to sum it all up then, what we've got here are 2 dates of interest. Both are just a few weeks away. We've got 29th of October, 11 hours 44 minutes. This is when Atlas 3I makes its closest approach to the Sun. Distance there, you can see. And then we've got 3rd of November, 5:56. And that's when Atlas 3I has its closest approach to Venus. But I'm focused upon the distance between Atlas 3I and the Earth at that time. And that distance is the 209.6 million miles or so. Upon both of these times, right, on either of these dates, it is possible that we could have an extreme solar flare, maybe a CME associated with it, or a high magnitude earthquake, okay? Both of these dates could be significant, maybe just one of them, and they could be significant, either of them. On either date, you could have a high-class solar flare or high magnitude earthquake. I throw in also possible auroral or atmospheric effects on the Earth, but I'm actually looking at those first 2 on the list here. So again, it's very speculative, guys, don't get me wrong, but the physics is so uncanny. It's very much in line with things I've seen before. So I would definitely say that these 2 things are dates of concern. All will be revealed. Something could happen on either of these dates. Maybe nothing happens. But I do think that the distances are energetically viable. And it does make me think about what's going on here. I think this Atlas 3I is some kind of alien probe. I think it chose a very specific path to go into our solar system, okay? A special hyperbolic type orbit. Well, not orbit, but trajectory. It's not an orbit, it's open-ended, so it passes through. But it was set up in such a way to have these special close points of approach to various planets. And I believe it is essentially scanning all of them via resonance. It is tapping into them via shooting wavelengths, so energy waves at them. But I don't believe of the electromagnetic spectrum. This is why we're not picking up anything blatant, you know. It is firing energy waves, I think, to all of them. It's scanning all of the planets in turn. Now, you might think of this as a scientific scan, and it may well be. But if it's causing resonance effects, what might be almost a mundane scientific scan, perhaps from an alien probe, could have very real implications for us on the Earth. If it can trigger earthquakes, if it could trigger solar flares or even CME events, you know, this could affect us, right? Even though it might be not necessarily intentional. It's hard to say, guys, but I'm pretty certain the data checks out. Atlas 3I is definitely not just some random comet. It absolutely is on an ordered, intelligent path through our solar system. The close approach distances are significant in terms of statute miles. The ratios are very accurate between close approach distances. No way is this random chance, no way a random orbit. And when you consider the physics of resonance tied into, you know, monuments like the Great Pyramid, the physics there, you consider the physics of nuclear weapons and some of the esoteric aspects there. When you look at these relations to existing solar flares, existing earthquakes, as far as I'm concerned, guys, there's something in this. There really is. These are definitely dates of concern. And who knows, maybe something will happen on them. I hope nothing, you know, horrible, but you've got to wonder, you know. That's all I can say. I can only leave it by saying if you want to know more, obviously go to my website, Lost Age Secrets. It's lostagesecrets.com. And this isn't the home page. You can go to the site menu and have a look at all topic areas I cover. But if you scroll down to the bottom, you can see both of my books here. Now, these are ebooks, so if you buy them now, you'll instantly get them downloaded to you as PDF files. We've got the lost age of cosmic harmony. This looks at the ideal solar system and some of the special units of measure we have. Then we've got ancient megaliths, covert military bases, nuclear weapons. If you like what I said about King and Bravo and you want more of that stuff, you'll definitely get it in that book. I tied together all kinds of things there, and that is what relates very strongly to the research I've just presented here. So we'll leave it there, guys, and we'll just have to see what happens on either of these two dates. So with that said, that's all I've got for now.